All right, welcome back. So in this part, I'm going to show you how to make a 3D printed fastener. So normally for most of my projects, I use thread forming fasteners. So basically what that means is that the threads of the fastener or the screw are cut at such an angle that they make, as long as you undersize the hole that it's going in, they make threads in the plastic as they're going in if you don't over torque the screw too much. So those are great. I usually get those on McMaster car, and they're super valuable for 3D printed projects. But for now, I want to make sure that we can build our project with everything in the kit, and so that we're not spending extra money, right? So I'm going to show you how to make a 3D printed fastener. Just a little introduction to them is that because it's plastic and there are some material restrictions, you can't go too thin with the threads on the fastener, and I'll explain more about that in a second. But basically, we have to make fasteners that are sort of large, and we couldn't get as small as a metal fastener because the threads would get too small where the plastic would just deform when you're twisting them down. So there's sort of a minimum size that you can use. So we're gonna create a decently large fastener, but let's show you how to do that. So we're gonna make a new part called named mine 3D printed fastener, and you're gonna start with the sketch on the top plane, and if you make a circle about the origin, and then you dimension it to be 10, and then we're gonna extrude this down 20 millimeters. So we have our cylinder. There's literally a function called thread, or a feature called thread that is perfect for this. So all you have to do to start it up is choose the edge of the cylinder that you make. And then I make sure you're on metric die. That's what I'm using. And then there's all these different sizes of different threads that you can pick. I went with a pretty large thread because I want my threads to be nice and thick, so you get a couple layers in each thread to make sure that they don't deform while you're twisting the fastener into its position. I went with 30 M30 3.5. The difference here is that so there's M30 by 2 and M30 by 3.5. The second number is the pitch, or the distance between the threads. So we want nice and big threads, those M30 threads, and then we want them pretty spaced apart so we have plenty of room to not break our plastic fastener as it's twisting into its reciprocating thread. So M30 3.5 is what I'm using for this example. We come down, the cylinder is only 20, so let's make sure we're going past that. So I made my end condition 30. And then the other thing to pay attention to is just make sure we're on cut thread, and then I'm going to show you what this looks like. So if that's all we do, it sort of stops, it doesn't go to the top of the fastener. Maybe there's an option that will quickly fix that, but I sort of came up with a little trick. So we're gonna offset the threads up and then cut off the extra so that it goes all the way to the top. Because if you do this, you won't be able to thread your fastener all the way down. So we're gonna use offset and go upwards, but you have to. A good recommendation is that you offset in increments of whatever your pitch distance is. So we chose M30 by 3.5 millimeter pitch distance. So we would want to move up in increments of 3.5. So I went up by 7, 3.5 times 2, and we're above our fastener and we're below our fastener. And then there's these great tools on the bottom called trim with start face and trim with end face, and that basically just means it cuts off all the extra. So then we'll press OK. So now at the top there's thread all the way to the top of our fastener shaft, and it goes all the way to the bottom, which is exactly what we want. So now I'm going to create the corresponding nut that the fastener goes into. So I'm going to make a sketch on the top plane, and I'm going to use this feature called polygon, and it's sort of already set up to create hexagons. And then I'll just dimension this, I don't know, 15. And then I'm also going to make a circle in the center that matches our diameter of 10 of the other fastener. And then I'm going to extrude all of this down. We'll do 10 millimeters. And this is going to be a new part, so it's not a merge. Boom. So now we have two parts. We'll name them. So this one's going to be our bolt. And this one's going to be our nut. And then now we have to make the threads for... So if we take a section view about the front plane, we can see better what's going on in the inside. So now we have to make the threads on the inside that correspond to the nut. So the trick here is to pick the edge of your cylinder that you made, of the like the inner cylindrical surface edge of your nut. And then we want to switch. You're going to keep the size the same, and then all you're going to do is change the thread method to extrude thread. And then we're going to do the same thing. So we're going to offset by 7 upwards and make sure that trim with start face and trim with end face are checked. Boom. Okay. So now I'm going to hide my bolt. And well, first, because this is a nut and bolt and they're like moving past each other, we have to give some clearance, right? The same thing as before. Remember with the ultrasonic sensor sliding into the tube? You can't have things that are like fitting in each other right on top of each other because of tolerance with your printer and a bunch of different variables that will affect like how your shapes come out. So you want to give a little bit of extra space for things to slide through each other. So I'm going to hide the nut because I'm going to hide the bolt because we have to give some clearance. So I'm going to do direct editing, move face. And my magic number was 0.3 that worked really well for me. And I'm going to select this face. And I'm trying to take away material. So I got to go in the other direction. And I'll choose the 2 thread faces and then the back cylindrical face. Make sure you get all 4. And I'll press OK. And now you can see that there's plenty of space. There's 0.3 millimeters on like every surface for the fastener to thread through. And once we finish this part, you're going to print this out and test it to make sure it works on your printer, like you like the tolerance and how it fits, because this isn't going to be true for like your 0.3 millimeter offset or of clearance worked really well for me, but you may have a printer that's more finely tuned or less finely tuned, or there's other different variables. Maybe you're printing with a different nozzle height or nozzle diameter. So there's a bunch of different variables that could affect clearance. So you're going to print these out and test this after this to make sure we're good before we move forward. And then because these threads are, so I'm going to hide the bolt again. And because these threads are sharp, I'm going to put a very small fillet on the edges because we don't want our threads to wear out. All right, that looks good. And we're going to bring our bolt back. And then I'm going to make a small little top portion of the nut or of the bolt. So we can like twist it down. That's pretty good. 12.5. I like that. And then we're going to extrude this up 5 millimeters. And then uncheck auto, select which body we want to connect to, and then just click our thread part of the fastener. And then one thing I want to add is this is going to help with the model later when we're like trying to put it in our assembly. If you bring your features all the way back to below the boss extrude, if you go to reference geometry and then axis, and you just select the cylindrical face, and you press check, now we have an axis to easily like mate things to when we want to like visualize this in our assembly and make sure everything fits. And then a couple more features to add, and then we'll be done here. I'm going to make a little box on the top of my fastener. We'll do 1.5 by 6. And then I'm just going to cut this out we'll go down like, I don't know, 2 millimeters. And basically this is, I was okay with twisting my fasteners by hand, but in case you wanted to use a screwdriver, you could stick a screwdriver in there and try and torque it down. But be careful because it's plastic and you don't want it to break. And then the last thing is if we hide the nut, we just have to add fillets on the threads of the fastener as well. So same thing, get the edges of the fastener and then the edges of like the cylindrical face behind it. Boom. And that's it. We have a fastener that's ready to 3D print. And this may look a little funny because the threads are really big compared to like the diameter of the bolts. Like this, we chose an M30 thread, and the bolt's diameter was 10. So it looks a little weird, but this is gonna make it so that like I'm pretty confident it'll work on like everyone's printer because the threads will be so big and they won't ever break, which is good, and that's what we want. So that's it for this video. I'll show you how to print this out, and then we're gonna test it. Make sure you like your clearance. If it's too tight or too loose, you can adjust the clearance with the move face command. And then we're gonna bring that into our design and start designing with those features. See you in the next video.